how would I draw this? If I'm showing a vector that is traveling due east, how would I draw it? Well, it's coming from the west, going towards east. From the north, well, if it's from the north, then it's actually traveling south. Southwest. So southwest means 45 degrees in between south and west. Any questions? Okay, bearing of 300 degrees. So we're talking about a bearing. So that means our zeros here. And this is where we're starting to count from, and we go in a clockwise direction. And so that's going to bring me into quadrant 2. There's my 300 degrees. Okay. 70 degrees west of south. So we are 70 degrees to the west from south. Okay. 70 degrees south from west. Well, now we're traveling from west to south and we're going 70 degrees this way. Okay. Any questions? Okay, this is very important, guys, because you're doing word problems in this section, and so you have to understand the difference between all these different ways of drawing your vectors, okay? Okay, so let's take a look at our first example. It says an airplane heading due north at 500 kilometers per hour encounters a wind of 150 kilometers per hour from 30 degrees north of east. Determine the resultant ground velocity of the plane. Okay, so we need a resultant vector. So I have to draw my vector that is going to represent the wind and the vector that's going to represent the plane. So I want you guys to try and do a diagram, and let's see how you do. So I'm going to give you just a couple minutes to think about that and draw your diagram, and then I will do it. So the first vector that you should draw is heading north, and we know that it has a magnitude of 500. The second one is the wind, and it's coming from 30 degrees north of east. So here's east. So I want to go towards the north 30 degrees. And it's coming from this direction. So my arrow's like this. Now, these are vectors. So what I need to do is I need to displace it in order to get a resultant. So I need to take this and put it here, right? To create the resultant. Okay. I'm just going to make it a bit smaller so that it fits in my screen. Everyone okay so far? Okay. And that means now that my resultant is there. So the plane was traveling this direction. However, the wind came and pushed it, and now it's traveling the path of the resultant vector. Okay? So what can I fill in here? Does anybody see anything that I can do? I need to solve for the magnitude of my resultant vector.
We know the values of P and of 150. No, sorry, and the wind of 150 kilometers per hour.
Beautiful. There we go. So I have two magnitudes right there. I have 150 and 500. Am I ready to solve for the resultant? Do I have enough
No.
information? No, it's not a right angle triangle. So I don't have enough information, but I can get more information. So what else do you see here?
It's 60 degrees. And you use Z pattern.
Beautiful. 30 plus 60 is 90. So I know that this angle is 60, and you're going to use the Z pattern. And so I know that this angle is 60. So now what I have are two sides and the contained angle. So go back to grade 10, grade 11. How can I solve for the magnitude of the resultant vector?
Cosine law?
Yep, cosine law. So go ahead and do that. And go ahead and give that to me with units to 1 decimal place, please.
$444.4 kilometers per hour.
Good. Excellent. Okay, am I done? Have I solved the question?
No, we need a direction.
Excellent. It's asking for ground velocity, right? And so I need a direction. So we're halfway there. So I need to find the direction. Which angle am I looking for? Which angle am I looking for?
Bottom one,
What's bottom one mean? So between which two vectors?
R and P.
Beautiful. So the plane was traveling north, but now it's been pushed. We want to know to what angle. What direction is the plane flying now? And so we want that angle theta that I've indicated there in green. Okay, how can I find that angle theta? Simple math. How can I find it? I want to find theta. What law can I use? Do I have to use the cosine law? Yeah, I'm going to use the sine law. So you're going to say the sine of theta over 150, the opposite side, is equal to the sine of 60 over your resultant vector.
Oh, miss.
Yeah.
Would it be incorrect if we solved for like the angle between west and R?
Between wind and R?
Like
Or
west.
no, west and R. Yes, it would be.
So it would also be acceptable to do that?
No, it's not. We want it the one between your resultant and the plane, because that's the way that it moved, right? The plane moved that way towards the resultant. The angle that you would be giving me, it still gives us a direction, but I want the direction with regards to the plane.
But like it would still be the same.
You would, yes.
So, okay.
Okay. All right, so here. Where were we here? Okay, so solving here, we're going to take the inverse of sine. I'm going to cross multiply. And so then theta is equal to, give it to me to the nearest degree.
17.
Yeah. Okay, and now our statement. Therefore, the resultant ground velocity is 444.4 kilometers per hour, and it's 17 degrees west of north.
So for these types of questions, we should always find the direction in terms of like whatever it is, right? So for example, in this case, it's the plane.
That's correct.
Okay, thank you, miss.
No problem. Okay. Any questions? We okay to go on? Okay, so a canoeist wishes to cross a river 1 kilometer in width. If the current flows at 5 kilometers per hour and the canoeist can paddle at 13 kilometers per hour in still water, determine the direction the canoeist must head to travel straight across the river. So let's draw this. We have a river, and I'm just going to draw my river like this. So what's happening is the canoeist wants to cross straight across the river, but there's a current. And so even though he's trying to travel straight across, the current will push him, right? So they want to know what direction should he angle himself so that when the current pushes him, he ends up going straight across, so that our resultant will end up like this. Okay. So basically we've got a current that is pushing him down. And so we want to know, well, at what angle should he angle himself? And you can either say the angle with respect to the resultant, or you could give it with respect to the bank. Okay, because we're going to use the words upstream or upstream, excuse me, or we're going to say from the bank. Okay. So what do? I have my resultant. This is my paddling vector. Here's the current. What can I do?
We know the paddling speed and the current speed.
Good, we do. So we know that we paddle at 13 kilometers per hour. The current is 5 kilometers per hour, and we have a right angle triangle here. So we just need to use SOHCAHTOA. So sine cos tan. What am I going to use to solve for my angle theta?
Sine.
Yep. So sine of theta is equal to opposite over hypotenuse. And so we have 5 over 13. And so I take the inverse of sine. And what do I get approximately?
22.62.
Okay, I'll just take it to one decimal point there. And so we say, sorry guys, give me 1 second. Okay, so therefore, the canoeist must travel 22.6 degrees upstream. And now you have to say from where. And so we're going to say from the riverbank or from the horizontal, okay? Cool. If we were, hold on 1 second. Yep. Now in this case here, if you wanted to, you could use your theta 1, which would be 67.4 degrees upstream. So that would be okay in this case. And the reason is because you're giving it with respect to a location. So with respect to the riverbank, right? Okay, the time it will take to cross the river. So how long now is it going to take to cross this river? So what information do we have here? How long is it going to take to cross this river? What do you guys think we need to do here?
So we have, Brian, you can go.
Okay, let's find the resultant using Pythagorean's theorem.
Yeah, why? You're right. We're going to find the
Oh.
resultant to find using the Pythagorean theorem. Why? Because ultimately, what do we need to do?
We need time, so it's distance
Yeah.
divided by velocity.
Beautiful. So I know that I need time, which is distance divided by velocity or distance divided by speed. And so that means I need to find the distance. Okay, and so we have to solve for the magnitude of r. And we're going to use the Pythagorean theorem. And what do we get here? $12. And then, as we said, we need time, which is distance over speed or velocity. And so what do I sub in?
1/12.
Excellent. They've already told us that the river is 1 kilometer in width, so we know the distance. And we found our velocity. Okay, so 1/12 of an hour, or 5 minutes. Therefore, it will take the canoeist what's Christian doing? Yeah, can you help him, please? 5 minutes to cross the river. Are there any questions here?
Wait a minute, so for a vector, are you supposed to include units, or does it really matter? For the magnitude of a vector, sorry.
In the statement you need it, you need your units, but within the question you don't need it.
Okay, so it doesn't
I
really
put it
matter
there.
in the question.
No, it doesn't matter. You're saying this
Okay.
right here?
Yeah, yeah.
No, it doesn't matter. I put it there just so people understand that we're finding velocity, that's all,
Okay.
right? I just don't want you, yeah. And that's it.
What do you mean
Yeah,
by in A?
I'm sorry, what do you need by? What do I mean by?
The horizontal in A.
Okay. Here, you're talking about here? This is my horizontal. I'm gonna highlight it for you. That's what we're talking about when we say the horizontal.
Okay.
Sorry, give me just 1 sec.